Review of final assessment graphs. In question number 1, the instructions read, determine the slope and the y-intercept, then graph the equation. So for question number 1, we're given 4x plus 5y equals 28. So the first thing I'm going to do here is rewrite this item into the slope-intercept form, so that I can find the y-intercept and the slope. So the slope-intercept form, if you remember, is y equals mx plus b. So I have a 4x plus 5y equals 28. So I need to isolate the y on its own. I'm going to do this by removing the x to the other side. So I'm going to subtract the 4x off both sides. I'm left with 5y equals a negative 4x plus 28. These two items were not like terms, so I'm just going to write them down. I'm going to put them in the order that I see up here in the slope-intercept, with the mx first and the b second. Next, I'm going to divide out that 5 so that the y is left on its own, so that I end up with a y equals a negative 4/5 x plus 28 over 5. So now I know my y-intercept. My y-intercept is the value that came out of the b position with the 0. It also needs to be inside parentheses and separated by a comma. So I have here parenthesis 0, comma 28 over 5. The 28 over 5 on its own is not the y-intercept. It's only a piece of the ordered pair. My slope for this one is a negative 4/5 x. Now that I have these two items, I can actually graph my problem. If I look at this, the 5 goes into 28, I end up with a 5.6. So if I came over to my graph on this one, I could graph a point at 0, 5.6. So the 5 is here, and halfway up, just slightly past the halfway mark is where my dot should go. So I end up with a 0, 5.6. Now, using the slope, which is a negative 4 over 5, I can find another point. So I need to come down 4 places. So I'll come to my graph, and I'll come down 4 places, remembering that I'm just slightly above the halfway mark each time for one place. So 1, 2, 3, and 4, and then come out a total of 5 places. 1, 2, 3, 4, 5. I put another dot. So I'm at 5, 1.6 for another point. Now I can draw my line in. I use the rise over run method to draw my line. I also could have chosen values and plugged them in for x or for y and solved for ordered pairs to graph. Now coming down, question number 2 says match the equation with the appropriate graph. So when we look at this equation, we have an x is equal to a negative y. So we need to match it to the appropriate graph. Well, if we look at the y in this case is actually a negative value. So the line is going to come in a downhill if you were to read it from left to right. So looking here, reading from left to right, when I look at equation A, reading left to right, this is actually going uphill. Equation B is actually going downhill, reading left to right, my line's going downhill. So A's out, B's still in, however, still a possibility. Also, coming down here, I see that my letter C is going downhill, reading left to right. My letter D, however, is going uphill if I read left to right. Look at it like a hillside. It's going uphill. So A and D are out because of the negative on the y. Now, let's think about absolute value. The absolute value of x is equal to the absolute value of y. This is a 1-to-1 ratio in the ordered pairs. Let's look at the ratio of the rise to run in each of these. If we look, well, I've got it up here, letter C. If I just picked a point where this line crosses on the axes, or it crosses, like for example, origin here, and then out here it also crosses. To line these up, I'm coming up one place and running two places to hit this next point. If I were to work the other direction, I come down one and run two places. I see I have a ratio where I have a 2-to-1 ratio. So C can't possibly work. But just to make sure I haven't made an error, I'm going to come back. I'm going to look at B as well. So if I start here at the origin, I have to come up one and then over one to hit the line. Up one, over one to hit the line. Up one, over one to hit the line. So again, I have a ratio of 1-to-1. So letter B is going to be my correct answer. Alright, question number 3. It says y equals a -3, and we've been asked for this one to determine which graph that's shown is the correct answer to go with this problem. So y equals a -3. So if we were to look in a book on page 202, there's a rule. It says horizontal lines. The graph of y equals c, where c is a real number constant, is a horizontal line parallel to the x-axis that passes through the y-axis at a point with coordinates of 0, c. So when I look down here at the graphs that are available, first off, let's look at A. A is not running horizontal, so I'm going to have to ignore A. Looking at B, it is running horizontal, so B is still a possibility. I see that the C is running vertical. It's running up and down, so C is out as well. So my two possibilities so far are B and D. So the next thing I need to look at in this one are the values. It told me in the page that my coordinates would be 0, c. Well, if I look up here and I look at this, y equals -3, the -3 is the c. So my line should be running through the ordered pair at 0, -3. If we look at B right now, 0, -3, so I'm not going to go left or right from the origin, but I am going to come down 1, 2, 3. That would be right here, 0, c. So B is not going to work. So we're going to come down here and look at D. We have 1, 2, 3. There it is. So D is our correct answer. Let's look at question number 4 now. It says write the equation of the line in slope-intercept form. So we're given on number 4 a line that's already been graphed, and we need to figure out what the equation is of the line and write it into a slope-intercept form. Now if you remember, your slope-intercept form is going to be y equals mx plus b. Well, the b is going to be part of the ordered pair for where the line crosses the y-axis. It's going to be 0, b is where the line crosses the y-axis. So if I look at this line here where it crosses the y-axis, it's crossing at 0, -7. So my b is going to be a -7. From there, I also want to find my slope. Well, slope can be found as a rise over a run. So when I look at this problem over here, I can pick 2 points on my line. So I've got 2 filled in here. I already have the y-intercept, so I came over and I picked the x-intercept as well. When I rise from that point up so that I'm even with that next point over here, I have to rise 5. And I'm rising towards the positive, so this is a positive 5. Then running towards the negatives to get to the point, -6. So my slope is a -5/6. Now I can plug this information in. So I have a y is equal to a 5/6 x minus 7. So now I've written this line in the slope-intercept form. I've completed the answer to the question. Alright, question number 5. This one just says graph. We have a function of x. It equals a negative x to the second power minus a 2x plus a 2. So looking at this, we have a quadratic equation because we have x to the second power here. So we're going to be graphing a parabola. So when you're dealing with something like that, start with a very simple number, like a 0, for example. I'm going to plug a 0 into the equation, and I'm going to solve to see what y is. So I take the equation down here. I've got x equals 0, so I've plugged a 0 into the x position, and I've solved out. The conclusion I come to is that y is equal to a 2. So I came back up here, I put it in my table, put the 2 here, and I'm going to come over and I'm going to put it on the graph. So I came over and I put on here 0 to a positive 2. 1, 2. I put a point and I labeled it. Don't forget to label your points. 0, 2. I labeled my ordered pair. So I don't know where this graph is going yet, so I'm going to try a 1 for my next one, because it's a really simple number. So I came down and I took x is equal to a negative 1 and I plugged it in. And I solved down the problem. I find that y is equal to 3. So I'm going to come back up here. I put that 3 back in my table. I come over to my graph and I put my point on. So it's a negative 1 up to 3. 1, 2, 3. Put the point, labeled the point, negative 1, 3. So with my 2 points here, I'm kind of going up and off to the side. So I want to see what maybe if the thing's going to continue up or if it was going to turn. So the next thing I chose over here when I went to plug it in, right? Whoops. I went to my negative 1. So I wanted to see if it was going to turn. So I'm coming from the negative 1. I'm going to see where it's going up or down. So I chose the negative 2. So I come over here. I plugged in an x equals a negative 2. I worked it out. I found that y is equal to 2. So I came over here and I put that 2 in there, and I see that this thing turned. So I see my parabola is starting to turn down, but I need a few more points in here. So I came back in and I also tried the negative 3, so I could maybe pull this line down. Also earlier, which I kind of skipped, but I tried a 1 as well, and I plugged that one in, and it started to create a shape. Now, when you're creating these graphs, you want to graph 2 or 3 points, see where it's going, and then try to pick some values where you think the parabola is going and solve for those. Put a couple more on. If you need to, then go on to a few more where you think the parabola is going. Once you, though, have enough points to make the parabola, which is typically at least 5, but it depends on the choices you made. You may need more than 5 before you can draw it out. Going on to number 6, it's the same type of situation. We're going to do the exact same thing. We're coming in, we're going to pick some values. So I started with the 0, and I plugged it in, and I solved it. Now when you're doing this on the test, make sure that you're showing your work down here. So I showed my work down here. I plugged it in, I showed the work, and I came back up here and I put it in the table. When I plugged a 0 in on the x, and I solved, I found that x was equal to 4. So there's my point. I then decided to go with a 1. So I did the same thing. Down below, right? I plugged an x into the 1 position over here, and I solved it out and found that y was equal to 3. So I put it in the table, and then I came and graphed it. So it looked like it's starting to come down. So I picked another point over. This time I wanted to see how far it's coming down because I'm pretty high up on it. So I decided to come over 2 more places. So I came over 2 more places, so I chose a 3 now, and I plugged it in. When I plugged that 3 in, I solved it down, and I ended up with a negative 5. Brought it back up, put it in the table, put the graph on here. So now I've got these 3 points that were coming up and starting to curve over. So I want to see where this thing's going on the other side. So I'd already done a positive one, so I decided to look on the other side into the negative, so I decided to do a negative one. So I did a negative one here. When I calculated the negative 1, I found that y was equal to a positive 3, so I ended up with a dot. So now I've got this parabola that's coming through, and it looks like I found the middle point at 0, 4. It looks like this thing's just going to continue and match the other side. Since it looked like it was going to match, I'd already done a positive 1 and a positive 3 and a negative 1. I decided, well, let's try the negative 3 and see if we can match it. So I plugged in the negative 3 and solved it and found that it was a negative 5. So when I graphed it, negative 3, negative 5. So now I've got enough points here that it made my parabola. Alright, so now we're down to question number 7. Solve the system graphically. So I have a 2x plus 3y equals 20 for one line, and a 3x minus 2y equals negative 9 for my second one. So what I'm going to do is I take the first one, the 2x plus 3y, and I'm just going to find 3 points so that I can graph this line. So I took that 2x plus 3y equals 20, and I just picked some values. So I decided to put a 0 on the y so that I could find the x-intercept. So I plug it in, and I find that my x-intercept is at 10, 0. So then I came in and I decided, okay, I see I've got an even value over here. If I put a 2 on the y, this will create an even number so that when I subtract, I still have an even number, so when that 2 divides through, I'm going to avoid a fraction. So I just chose a 2. If I chose a 1, I'd end up with a fraction. I'd have an odd number over here. So I'm going to stick to even numbers to plug in on the y. So I plugged a 2 in. When I solve this down, I end up with my x being equal to a 7. So I have a 7, 2. Then I wanted one more. So again, I picked an even number, a 4, to plug in on the y, so that it would make an even number over here that would have to subtract from this even number, so that I get an even number that 2 would divide into. And it gave me a 4, 4. Once you have that, come back up, graph your 3 points. This is going to be your check. If your 3 points line up with one another, then you've graphed correctly. Next, I come in and take the second line, the 3x minus 2y. I'm going to graph this one. So I brought it down here. Again, I decided to put a 0 on the y. It's nice and simple. It'll show me where my line is actually crossing the x-axis. So I plug it in, and I end up with a negative 3, 0. Now this time, when I look at it, I have a negative value over here. So I'm going to, with my y, I'm going to choose values. I'm going to choose values that are odd. Excuse me, not a negative. I have an odd number over here. So I'm going to choose numbers that are odd to plug into with this 2 so that I end up with an odd number, or excuse me, so that I end up with a number that will clear the 9. So it's an odd number, and it's also a 3, so that I make a 6. I can see this visually. I don't have to do the math. I can actually do it in my head there. I can visually see that by putting a 3 here, it makes a 6. That'll leave a 3 over here. So the 3 worked really well. Plugged it in. I avoided creating a fraction. So I end up with a negative 1 over 3. Then I also chose a 6 in the same fashion. Chose that odd number. So I get a 1, 6. Came back up here, graphed these. So I graphed these points, and when I put them on here, it looks like my line, I hadn't graphed a point on the blue one yet that was at 1, 6, but it looks like they're intersecting at 1, 6. I know for sure that my green line is going through 1, 6. This is actually one of the points that I plotted. I want to double check it though, make sure my line isn't going a little wonky or a little sideways. So what I would do is take that 1, 6 and check it. I'm not showing the check here, but run a check. Take the original number, or the first one, which was my blue line, which is my 2x plus 3y equals 20, and plug into here my 1, 6. So, and see if it creates a true statement. So 2 times a 1 plus a 3 times a 6 equals 20. So I end up with a 2 plus 18 equals 20. So 20 equals 20. So my answer is the ordered pair 1, 6.